Section 11.4, equations, quadratic in form. I'll explain the title shortly. So let's consider the following problem. By the way, these are on pages. All the problems we're going to be doing in this section are going to be on pages 827 through 828. Let's do number 2 on page 827. So the question is, solve this equation, x4 minus 13x squared plus 36 equals 0. So we've learned so far how to solve quadratic equations. This equation is not quadratic, but it's quadratic in form. By this we mean that if you do a certain substitution, you can turn it into an equation, a quadratic equation. And look, observe the following. How about we make the following observation. The square of the square, right? X squared, the whole thing squared, is x to the power 2 times 2, right? Which is 4, correct? So you multiply the powers. 2 times 2 is 4. Okay, so if you make the following observation, then you can rewrite this as, these are equivalent. x4 can be rewritten as the square of the square, like this, minus 13x squared plus 36 equals 0, right? They are the same equations. Correct? Now, you see this variable here, x squared? That's the same guy as this. So how about we introduce a new letter for x squared? If you introduce a new letter for x squared, how about y? So how about introducing the letter y to be x squared, right? So we're introducing a letter y that denotes the square of x. As such, this becomes what? This becomes the square of y, correct? Because x squared is y. I labeled it as y. This becomes the square of the y minus 13y, right? X squared is y, plus 36 equals 0. So these two equations, this pink one and the blue one, are the same once you introduce this variable. As such, look at the final, look at this equation. You see this boxed one? This is quadratic because this guy is a second degree polynomial and it equals 0. So this is a quadratic equation. So hence the title. You see the title here? Quadratic in form. So even though at first the equation doesn't look quadratic, because here I have power 4, however, upon a certain substitution, it becomes quadratic. Okay, so it's in form quadratic. All right. So now I need to solve for y. I need to solve for y in this equation. So I'm gonna invoke quadratic formula if necessary, or I can rely on some intuition. How about you do it via quadratic formula, and what you should get, if you have a good intuition into it, great. If not, please use the full power of quadratic formula. It's a robust approach. It works all the time. And what you should get is y minus 4 times y minus 9, right? Remember, quadratic formula allows you to factor a second degree polynomial under a certain or a couple of conditions, right? The a should be non-zero, which is the case because a is 1 here. And the other condition is b squared minus 4ac to be non-negative, the discriminant that pertains to the second degree polynomial involved in this game. If you do b squared minus 4ac, you're going to find a non-negative entity. In fact, in this case, it's going to be a perfect square, and as such, you can find the m and the p in the previous section and factor that guy, right? And the factored form is going to be like this. Okay, what does it mean? So what does this mean? This means that either y minus 4 is 0 or y minus 9 is 0. Why? Because of the zero factor property, right? Because of the zero factor property. Let me label all these guys. So how about I label this as QF, quadratic formula, and how about this, the zero factor property. Okay, ZFP, zero factor property. All right. Okay, so this means that y is 4 or y is 9, right? Agree with this? All right, so but this is not the end of it, because y is an auxiliary variable that we introduced to the problem. The problem was given in terms of x, remember? The black equation. So y is something we introduced in order for us to be able to solve the problem. Now we need to translate, now we know what y is, right? Now we know what y is. We need to translate it, or translate information to the x environment in some sense, and hence the solutions, try to find the solutions of this equation. Okay, so y is 4 or y is 9, but y is x squared. Y is x squared. I'm trying to transport information from the y environment to the x environment, and this is the relationship between y and x. All right, y equals 4 means what? Means x squared is equal to 4. Why? Because look, x squared is y, right? So if y is 4, this is the same thing as x squared being 4, or x squared being 9, right? Makes sense? So what happened here? So what happened over here? We know that y is defined to be x squared. This is what we defined y to be. It's right there. It's right there. So I'm using it, and I'm going back to what y means. Y means x squared. So replace y by x squared, and you get this. All right. And if x squared is 4, what can you say about x? So a squared equals b is the same as, and b is non-negative. This is the same thing as saying that x is plus or minus square root of 4, right? Okay, let me label what I'm using here. So let me label this equivalence for you. So what I'm using here is the fact that if a squared is equal to b, with b being non-negative, that's the same thing as saying that a is plus or minus square root of b. Remember this previous section? So that's what I'm using. So here I have a squared equals b, and b is non-negative. B is 4 here, and a is x, right? So this means x is plus or minus square root of 4. So plus or minus square root of 4. Or similarly here, x squared equals 9, so x is a over here, and 9 is b, and certainly 9 is non-negative, so this means x is plus or minus square root of 9. Make sense? So I used this a couple of times. All right, what's square root of 4? It's 2. And what's square root of 9? It's 3, right? So we get x is either negative 2 or plus 2, or x is plus or minus 3. So or x is minus 3 or x is 3, right? Okay. So all these guys are going to be the solutions of this equation, the black equation. Okay, so this equation has 4 real solutions. So the solution set is given by the singleton minus 2 plus 2 minus 3. I didn't mean to say singleton. The quartet in this case, minus 2, 2, minus 3, 3, right? Okay. All right. So let me just try to. So we've done it algebraically, right? So everything here is algebraically. So geometrically, what are we trying to do? We're trying to match the graph of this function x4 minus 13x squared plus 36 with 0. We're trying to find for which x the two functions meet. The function y equals 0, which is the x-axis, and the function x4 minus 13x squared plus 36. However it looks, I'm trying to find where the two intersects. In other words, I'm trying to find where this graph crosses the x-axis, correct? And as it happens, we found that it crosses the x-axis 4 times at minus 2, 2, minus 3, and 3. All right, so let me actually take you to Desmos, a graphing tool online, and let me graph this function for you. So the function is x4 minus 13x squared plus 36, right? And we found minus 3. You see the graph? The graph is something like this, okay? But this is the x-axis. It looks like it's crossing it 4 times, and we found them, right? You see this point? Minus 3 comma 0. This is when the x is negative 3, the y value is 0. Minus 2. At 2, when x is 2, the output is 0 as well. And when x is 3, the output is 0. Right? So we found these guys. But we found even more than this. We found that there is no other ones that do the job. There's no other locations that the graph passes the x-axis. The graph doesn't indicate this, because who tells you if I don't scroll this way forever? Who tells you that if I keep scrolling I will not find the function anymore, right? So the algebra kind of guarantees that there's no way it's crossing more than these 4 times. Okay. All right, moving on. Let's do another problem. How about we do number 8? So we have x plus square root of x minus 6 equals 0. Okay, so here if you look at square root of x and you contrast it with x, well, x is the square of the square root of x, right? Do you agree with me? If you square the square root of x, that's exactly x. Am I correct? So because of this observation, what I'm gonna do is I'm gonna rewrite this as the square root of x squared, this is the x guy, plus square root of x minus 6, correct? So the green equation and the black one are the same, because of the pink, purple observation, right? If you square the square root of x, you get x. Make sense? So because of this, I'm gonna rewrite x. I'm gonna rewrite x as the square root of x squared. So this is what I did. I rewrote this guy as the square of the square root of x. And then I kept everything the same. All right. And now as we did above, Look, this guy and this guy are the same. So if you relabel the name, if you relabel this guy, it's gonna be quadratic. Let's do so. So let's introduce the letter, I don't know, maybe y, t, z, whatever. So t to be square root of x. Let's introduce t to be the square root of x. And then as such, this becomes t squared plus t minus 6 equals 0, right? Because I relabeled square root of x to be t. So this becomes t squared plus t minus 6 equals 0. Okay? All right, so this is now clearly quadratic. On one side, second degree polynomial, the other side 0. So this is the standard form of a quadratic function, a quadratic equation. And now I'm gonna solve it. So I wanna factor the left-hand side. And if you wanna factor it using quadratic formula, be my guest. So we've done many problems that pertain to this. So I'm gonna tell you that this, I mean, the discriminant here is a perfect square, so we can use a little of intuition here. The sum of, anyway. So if you don't see it, use quadratic formula. So this is t minus plus 3 times t minus 2 equals 0. Okay, if you want to check the work, void this out. T times t is t squared. T times negative 2 is negative 2t plus 3t is plus 1t. Plus 3 times negative 2 is minus 6. Okay, equals 0. Sounds good. All right, and this is the same as t by the zero factor property. Okay, let's do it anyway. So the zero factor property. Remember the zero factor property from the previous section? The product is 0 if and only if at least one of the factors is 0. All right, so t plus 3 is 0, or t minus 2 is equal to 0. Okay, and this is the same as t is equal to negative 3, or t is equal to 2. Very good. All right, so we're not done, obviously, because the question was in terms of x. They wanted to solve for x that do or does this job, the black job, right? Well, we translated this problem into this blue problem, the blue equation. And what did we do? We found the solutions of the blue equation. And now we want to transport, or we want to translate information all the way to the x environment via this transformation, via this relationship between t and x, right? The t is square root of x. So this is the connection between the t environment and the x environment. Make sense? All right. We know what t is. Now the question is, reveal what x should be, if any. All right, t is square root of x, right? So this guy becomes then, this compound equation here becomes, because t is the square root of x, as we just said. So because t is the square root of x, this equation becomes square root of x minus 3 equals minus 3, right? Or t is square root of x, correct? It's right there. Square root of x is equal to 2. Very good. I want to reveal what the x is. All right, look at this. Square root of a number is negative. Can this happen? Can this happen? I mean, square root of x, this guy here is at least 0, right? This guy here is at least 0. Square root of any non-negative number, I mean, We've talked about this in the square root section. Square root of a radicand, whenever it makes sense, is always non-negative. All right, and then as this is for all x that are non-negative, right? Whenever this makes sense, that's what I mean. So no matter what x you choose that makes sense, that makes this expression meaningful, and such an x is non-negative, that expression is at least 0. It doesn't drop below 0 no matter what x is. That's what we're saying. And you want to equate it to a negative number? This can't happen, because the worst it gets is to 0, right? Otherwise it's positive. There's no way I'm gonna let this expression meet -3. Make sense? So what you can say here is that this guy is not producing any solutions. There's no x that does this job. As such, we can throw this away. Make sense? And I'm only left with this guy. So this whole expression, this whole statement then is equivalent to square root of x equals 2. One more time. This boxed equation produces no solutions because there is no way I'm letting this guy meet -3. This guy, the least it meets is 0. This guy can never drop below 0. So there's no x that makes this equal -3. As such, keeping it or throwing it away is the same thing. It's not producing any it's not offering any information. So throw it away. And don't lose any information, hence the equivalence, right? So the whole thing reduces just to this part. So the solutions of this equation are the ones I'm gonna keep. And this is a meaningful thing, right? There is a way that square root of x is equal to 2. And that guy, what is it? It's 4, right? So if you let x equals to 4, you got it, right? Because square root of 4 is 2. Makes sense? All right. So what's the solution then? Solution set? It's simply the singleton 4. Okay. All right, next. Let's go to same page. How about going to number about 16? It's pretty much close to this. So here we have x2 minus 2 squared minus x2 minus 2 equals 6. All right, so this looks a little complicated. It's tempting to FOIL this and so on. I'm not gonna FOIL this. We can, but it's already at a stage where I can handle by doing an appropriate substitution. Look, it's already highlighted. You see this guy? That's the same as this. So if you relabel this guy, it becomes a quadratic equation. So how about we introduce a label for this highlighted expression? So how about we introduce some letter y, let's say, to be the label for x squared minus 2. Okay. All right. As such, this equation becomes the same as y squared, right? The whole thing inside is y. We labeled it as y. This becomes y squared minus y equals 6. Okay, this is quadratic. If you want to write it in standard form, y squared minus y minus 6 equals 0. Am I correct? Y squared minus y minus 6 equals 0. Okay. All right. This quadratic equation is very similar to the previous problem, but before we had a plus here. Okay, so if you don't see the factored form of this, how about using the full power of quadratic formula and get y minus 3 times y plus 2 equals 0. Okay, you can check. Y times y is y squared. Plus 2y minus 3y, I'm foiling mentally in some sense. So y squared plus 2y minus 3y is minus y minus 6 equals 0. And this means that y, by the zero factor property, let's leave it there, zero factor property, we're gonna get y minus 3 is 0 or y plus 2 is equal to 0, which means either y is 3 or y is negative 2. Okay, same story. Y is an auxiliary thing. The problem was given in terms of x. So let's take back what y means to us. It's x squared minus 2. So, all right, so y means x squared minus 2. So this means x squared minus 2 is equal to 3, or x squared minus 2 is equal to negative 2, right? And this is because y is, based on our introduction, was x2 minus x squared minus 2, right? So we get this. All right, let's solve for x. X squared minus 2 equals 3. If you add 2, you get x squared equals 5. And over here, if you add 2, you get x squared equals 0. Correct? And now I want to re-involve I want to involve this again, this bubble here that you see. Remember this? I want to involve it again. How about we copy it? So I'm going to involve this guy. Where am I going to involve it? I'm going to involve it here and here. Okay. What does it say? It says if B is a non-negative entity, and you are trying to solve for A, the equation A squared equals B, then A is plus or minus square root of B. We proved this in the previous section, if you remember. Okay, so if you want to revisit this, please go to the other video. All right, the video of the quadratic formula, right? Okay, so for the first one, A is x and B is 5, and clearly B is non-negative, right? So we're gonna use it to obtain x is plus or minus square root of B, which is 5 in this context, or we can use it again here where B is 0, and we get that x is plus or minus square root of 0. By the way, B being 0 is certainly a non-negative entity. 0 is bigger than or equal to itself. So we get A, which is x, is equal to plus or minus square root of 0. What's square root of 0? 0. And plus or minus 0 means 0 because 0 doesn't have a sign, right? It's a neutral element. So A is 0. This whole thing means x is 0. Make sense? Okay, so what do we get at the end of the day? We get three solutions, plus or minus square root of 5 and 0. Okay, so the solution set is minus square root of 5 plus square root of 5 and 0. So this triplet is the solution set of the equation that we see in black here, right? Okay. Let's do number 22. So the problem reads as follows. 20 times x to power negative 2 plus 9 times x to power negative 1 plus 1 equals 0. Okay. All right. So how about we make the following observation? X to power negative 2 is the same as the square of this guy, right? So the claim is that this guy is the square of this guy, as we used to do above, which is not hard to believe once you write it out in some sense, right? By one of the properties for exponents, you're taking the power of an exponential expression, you keep the base and you multiply the powers. 2 times negative 1 is negative 2, correct? So we end up equating the two. All right, so let's rewrite this as 20 times the square of negative x to power negative 1 plus 9 times x to power negative 1 plus 1 equals 0. Correct? And now let's highlight what we just observed. That guy and that guy are the same, so this whole thing becomes the square of that guy, right? All right, as such, we're going to introduce a new variable. So we're going to introduce a new variable. How about z as a variable? So that's the guy x to power negative 1. Okay. By the way, x to power negative 1 is 1 over x, right? Okay. All right, and as such, this equation becomes 20 times z squared. One more time, I'm relabeling x to power negative 1 as z. So this becomes z squared plus 9z plus the 1 equals 0. Correct? And we're gonna solve this quadratic equation. So we're gonna use quadratic formula for it. Or if you have intuition into it, great. So you can just use the intuition. Since I didn't use quadratic in the previous discussions, how about I use it now? So we use quadratic formula to factor this, to factor 20z2 plus 9z plus 1. If you see it again, great, okay? Oh, you don't even need to do all of this. All right. So with a equals 20, right? Coefficient of z squared, plus, or b is 9, and c is 1, right? C is the constant part, and b is the coefficient of z. Okay, or x at the time, remember? All right. So what's the discriminant? B squared minus 4ac. Well, the discriminant is b squared, which is 9 squared, minus 4 times a, which is 20 times the c, which is 1. Okay, and this is, what's 9 squared? 81 minus, how about all this guy? 4 times 20 times 1. Well, 4 times 20 times 1 is 4 times 20, and 4 times 20 is 80. And this is simply 1, right? Okay, so as such, the m that we used to say, that we used to call, which was by definition negative b minus the square root of the discriminant divided by twice a. In this context, it becomes minus the b. Who's the b? It's 9 minus the square root of our discriminant, which is 1, divided by twice a, and twice a is 40, right? Because a is 20. Okay, so that's then square root of 1 is 1, negative 9 minus 1 is negative 10. over 40, which is negative 1 over 4. So the m guy is negative 1 over 4. How about the p one? How about the p guy, which was minus b plus the square root of the discriminant divided by twice a. Okay, the only change is that this guy is going to turn into a plus. So negative 9 plus the square root of 1 divided by 40. And what's, one more time, square root of 1 is 1, minus 8 upstairs divided by 40 is minus 8 upstairs because minus 8 plus 1 is minus 8. And this is negative 1 over 5, right? So what can we infer up to this point? We can factor 20. So the quadratic formula tells us that the 20z squared plus 9z plus 1 factors as a, which is 20, times x minus m, who's m? Minus 1 over 4. So x minus vm, but m is minus 1 over 4, so that's minus the minus is plus 1 over 4, right? One more time. X minus m, that's the formula. X minus m, but m is negative 1 over 4, so it becomes x minus the minus 1 over 4, so it becomes x plus 1 over 4. You know what? I'm going to write it just in case any of you is lost. So this is x minus m, right? This is the formula, and m is minus 1 over 4 times x minus p. How much is p? Is minus 1 over 5, right? Agree with me? Okay. And that's 20 times x plus minus the minus. The opposite of something is the thing, right? Plus 1 over 4 times x, same story, plus 1 over 5. Makes sense? Okay. Some of you probably found, let me write it in a different color and then erase it. So some of you probably found 4x plus 1 times x 5x plus 1. Okay. Probably some of you found this by either a different method or using intuition or something. I mean, look, if you FOIL this out, you get exactly this. Okay. Try it. The idea is what we also found is the same. So how are they related then? Well, look, the 20 is the same as 4 times 5, correct? The 20 is the same as 4 times 5. Keep the rest. X plus 1 over 4 times x plus 1 over 5, correct? And the language here is multiplication. Multiplication is commutative. It's commutative in the sense that I can shuffle them around. The order doesn't matter, right? So what I'm gonna do, I'm gonna shuffle this factor and this factor. I'm gonna let them swap places, these two factors. And if they do, you can rewrite. Let me take this one a little down. And once they swap spots, let's say, we get 4 times. Let me go to the pink. So we get 4 times the x plus 1 over 4 times 5 times x plus 1 over 5, right? Correct? What I've done is, this is one of the factors. It's a product of 4 entities. 1, 2, 3, this package, and 4, the last package. What I want is, I'm gonna shuffle the spots of, or reorder them. Instead of having 5 as the second, I wanna have this package as the second, right? And 5 as the third. Multiplication is commutative. I can reorder the factors and get this. And also multiplication is associative. Multiplication of real numbers is associative, which means I can group them the way I want. I have 4 factors here. I can group them the way I want. I'm going to group the first 2. I'm going to multiply by the result of the second 2. Right? Now what is this? What's 4 times x plus 1 over 4? Isn't this one? Because 4 times x is 4x, and 4 times 1 over 4 is 1, right? And isn't this guy this guy? 5 times x is 5x. 5 times 1 over 5 is 1. So they are the same then. So what we found via quadratic formula and what you found via other method, intuition maybe, are the same. Okay, so I'm going to just erase this discussion. All right, let me actually box it and delete it. All right, oops. Okay. All right, so let's not lose track where we are. Where are we? We are at a point where we now factored this guy. So now this equation, how about we give it a name? How about we call it star? Equation star now is equivalent to thus equation star is equivalent to, remember in star this guy was the left hand side, but this guy can be factored as this, so we can write 20 x plus, oops, sorry, I meant z, well, I don't know, okay, I meant z here, and obviously I meant z over here as well, right? There's no x at this point, so z, 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 and z, right? Okay. All right. It's good to switch letters from every now and then because your intuition gets all the time to x, so don't be just accustomed to a variable labeled x. It's good to change letters. Okay. Anyway, so z plus 1 over 4 times z plus 1 over 5 equals 0. This is star, right? The left-hand side of star is this guy, but this guy can factor as such. Right there, equals 0. All right, let's solve this. By the zero factor property, what can we say? One of the factors should be 0. The zero factor property. One of the factors should be 0, but it's not the pure constant 20, right? It's not the 20 who's making the product 0. It's either the z plus 1 over 4, that's 0 and hence making the product 0, or the z plus 1 over 5 is the 0 who's making the product 0, which means z is negative 1 over 4, or z is negative 1 over 5, right? Okay, but z has nothing to do with the problem except when I introduced it right there. Z is the reciprocal of x. Z is the reciprocal of x, because I wanted to solve this pink problem, right? Z is the reciprocal of x, so let's go back to the x environment. Now I know what z should be. So z is, so since z was introduced to be x inverse, and x inverse is 1 over x, right? Okay, so this becomes then, instead of z now, I'm going to replace by 1 over x. 1 over x is negative 1 over 4, or 1 over x is negative 1 over 5, correct? Okay, now I want to solve for x. Well, you can cross multiply, you can do whatever you want. You can multiply by 4x both sides here. You can do whatever you want, but it's sort of like self-explanatory. Look, the reciprocal of x is, what's this? Minus 1 over 4 isn't the same as, because this minus can either go upstairs or downstairs or at the level of the fraction bar, right? How about I erase it from here and I take it downstairs. And now read this. The reciprocal of x is the reciprocal of minus 4, right? The reciprocal of x is the reciprocal of minus 4. So what should x be then? It's minus 4, right? And similarly here, same story. X is going to be negative 5, right? So these are the two solutions for the pink equation that we had on the previous page, namely this. Okay, so you see how we turn this problem, this looks uncharted territory, right? But once you see the trick, that x to power negative 2 is x to power negative 1, the whole thing turns into quadratic equation, or quadratic formula kicks in. It solves the problem technically, right? Okay. Solution set is simply those two guys, negative 4 and negative 5. Okay. All right, let's do another problem. How about number 32? 32 reads as follows. So I have x minus 10 over x squared plus 6 times x minus 10 over x minus 27 is equal to 0. Okay. So again, by now you should see that this is quadratic in form. If you realize that this variable and this variable, or this expression, are the same, they're the same expression, and here it's the square of that expression, so this looks quadratic upon relabeling that expression. So introduce the variable. Let's choose a different color. Let's choose the variable this time to be I don't know, s, to be x minus 10 over x. As such, this thing is the square of s plus 6s minus 27 is equal to 0, which means that, again, if you want to use quadratic formula, go for it, which means s plus 9 times s minus 3 is equal to 0. Okay. And this is the same thing as saying, by the zero factor property, that s plus 9 is equal to 0, or s minus 3 is equal to 0, right? Which means s is negative 9, or s is plus 3, right? All right. But what's s? S is x minus 10 over x. I want to carry information from the s environment to the x environment, and this is the relationship. So s is, since s is x minus 10 over x, what we get is, we get x minus 10 over x equals negative 9, or x minus 10 over x equals 3, right? Okay. All right, how can we proceed here? Well, how about we multiply both sides by x? Obviously x is not 0 here, right? I mean, all along x is not 0. I mean, look at the question. If x is 0, the question is not meaningful, right? So the provision of the question is that x is not 0. Let me actually box this for you here. So the provision of the question, x is certainly not 0. Why one more time? Because if x were 0, then this equation is not meaningful, because there are expressions within the equation that are undefined, that do not make sense, right? 10 divided by 0 doesn't make sense if x is 0, right? So since x is not 0 all along, how about we multiply through by x? We multiply through by x, and we can do so. We can multiply an equation by any non-zero entity and pick up an equivalent equation, right? And that x that I'm multiplying with is not 0. It's part of the provision, right? So since x is not 0, let me just label the equivalence here. So since x is not 0, see provision above, right? So we get, I'm multiplying through by x. All right, I'm multiplying through by x times, you know what? I'm gonna write the details. I'm multiplying both sides by x. So this side is x minus 10 over x. Okay, that's this guy. And then that's equal to minus 9 times the x that I just talked about, right? I'm multiplying both sides by x. Make sense? We're gonna do the same thing over here. We're gonna do the same thing over here. So we're gonna multiply both sides by x. So let me rewrite what I have. And now I'm multiplying both sides by x, which means I'm gonna have this times x and this times x. Okay. All right, let's multiply by x. Then x times x is x squared. And x times negative 10 over x is negative 10. Make sense? One more time. X times x is x squared. And x times negative 10 over x. X times 10 over x, the x's cancel. And what you get is negative 10. Equals negative 9x. Aha, this looks quadratic over here. Or same game. X times x is x squared. And x times this quotient, x times 10 is 10x over x. 10x over x is 10. With that negative sign, equals 3x. Agree? Okay, so each one of these looks quadratic. Okay, it's weird. The whole thing was quadratic in form. The whole thing was quadratic in form. We managed to find a good substitution for this, I mean, a new letter, to turn this whole equation, the initial equation, into quadratic. And then we solved for it, and we encountered, back when we are transforming information from the S environment to the X environment, we discovered that we are also encountering another or others other equations that look like, or that are quadratic actually. Okay. All right, that's fine. Okay, so this is then the same as x squared plus 9x minus 10 equals 0. What have I done here? I just moved the negative 9x to the left side by adding 9x to both sides to get this. Or I'm gonna add negative 3x to both sides and get x squared minus 3x minus 10 equals 0, right? And this is equivalent to, so we can use quadratic formula for this, but this is not too bad to factor. This is x plus 10 times x minus 1 equals 0. Or similarly here, you can either use intuition or quadratic formula. So we're gonna get x minus 5 times x plus 2, right, equals 0. All right, and that's equivalent to, for the first equation, by the zero factor property. I forgot to label these. So the zero factor property and here quadratic formula. By the zero factor property, what do we obtain? We obtain that x plus 10 is 0, or x minus 1 is 0. This is for the first. Or, similarly for the second, x minus 5 is 0, or x plus 2 is 0, right? And this is equivalent to saying that x is either negative 10 or x is 1, right? I'm solving each linear equation in this case in one variable, so this is easy. You just add negative 10 to both sides, add 1 to both sides, and so on. Or x is equal to 5, or x is equal to negative 2, right? So what are the solutions of the equation in 32? We got 4 guys, negative 10, 1, 5, and negative 2. So solution set is given by this quartet minus 10, 1, 5, and negative 2. Okay. All right, so this ends this section.